What would it be like to wake up in New York and within a single second be standing in Tokyo? No flights, no waiting, no distance. Just a moment and reality rearranges itself. Teleportation. If you think about it, it solves one of the most fundamental problems of human life: distance. Because no matter how advanced we become, moving from one place to another always takes time. And deep down, we don't really care about the journey. We care about being there. Now imagine if that journey simply didn't exist. You step into a machine, press a button, and instantly appear somewhere else. No delay, no motion, no in-between. Just here and then there. It feels almost magical. But science doesn't deal in magic. It deals in rules. And when we ask whether teleportation is possible, we're really asking, do the laws of the universe allow something like this? To answer that, we first need to understand what teleportation actually means. Because it's not just moving very fast. Teleportation is something far stranger. It means taking an object, breaking it down completely into information, sending that information somewhere else, and then rebuilding the object exactly as it was. It's less like travel and more like copying and pasting reality itself. Think of it like sending a message on your phone. When you send any text, the actual message doesn't travel through space. It gets converted into digital data, transmitted, and then reconstructed on another device. Now imagine doing that, but with your entire body. Every atom, every molecule, every neuron, every memory. That's what real teleportation would require. And surprisingly, science has already taken the first step in this direction. Scientists have managed to achieve something called quantum teleportation. Not with humans, not even with objects, but with the smallest building blocks of reality. At the quantum level, the universe behaves in ways that feel almost unreal. There's a phenomenon called quantum entanglement, where two particles become deeply connected. So deeply that if you change one, the other changes instantly, even if they are separated by vast distances. Einstein himself found this so strange that he called it spooky action at a distance. But here's something even stranger. This instant connection doesn't actually transfer usable information faster than light. Because hidden within quantum mechanics is something called the no communication theorem, which prevents entanglement from being used for faster than light messaging. So even though the universe allows this deep connection, it still protects causality, the idea that cause must come before effect. Using entanglement along with classical communication, scientists have been able to teleport the quantum state of particles. In experiments, they've taken the quantum state of a particle, essentially its identity, and transferred it to another particle somewhere else. The original particle loses that state, and the new one takes it on perfectly. It's not the particle that moves, it's the information that defines it. This connects to a deeper idea in physics, that reality itself might fundamentally be information. Some physicists even describe the universe as a kind of computational system, where particles are just carriers of information. If that's true, then teleportation isn't about moving matter, it's about rewriting information in the universe. But here's where things start to get complicated. Teleporting a single particle is one thing. Teleporting a human being is something entirely different, because you are not just a particle. You are made up of around 10 to the power of 28 atoms, all interacting in incredibly complex ways. Every cell in your body, every electrical signal in your brain, every tiny quantum interaction, all of it would need to be measured, recorded, and recreated perfectly. And that leads us to the first major problem. The amount of data required to describe a human being at the atomic level is unimaginably huge. In fact, according to estimates from physics and information theory, storing the exact quantum state of a human would require more bits than could be stored in all the matter on Earth. Just scanning your body alone might take longer than the age of the universe. But even if we somehow solved that, there's a deeper issue built into the fabric of reality itself. According to quantum mechanics, there's something called the Heisenberg Uncertainty Principle. It tells us that we cannot simultaneously know both the exact position and momentum of a particle. The more precisely we measure one, the less precisely we know the other. In simple terms, the universe doesn't allow perfect measurement. And this connects to another concept called the quantum no-cloning theorem. It states that it is impossible to create an exact copy of an unknown quantum state, which means that even in principle, perfectly copying a human at the quantum level may not be allowed by the laws of physics. So, even before we talk about engineering challenges, the universe itself might be saying no. But let's say, somehow, we overcome all of this. We develop unimaginable technology. We find ways to scan every atom, bypass quantum limitations, and reconstruct matter perfectly. There's still one final problem left, and it's not technological. It's philosophical. When scientists perform quantum teleportation, they don't move the original particle. They destroy its state and recreate it somewhere else. The original is gone, completely. Now apply that to a human being. If you step into a teleportation machine, your body would have to be completely deconstructed, atom by atom, in order to extract the information needed to recreate you somewhere else. In that process, the original you would cease to exist. What appears on the other side would be an exact copy. It would have your memories, your thoughts, your personality. It would believe it is you. But the question is it really you? Or is it just a perfect replica that continues your story? This leads into one of the deepest ideas in philosophy of mind, the continuity of consciousness. Your sense of self feels continuous, like an unbroken stream. But if that stream is interrupted, even for a moment, and then restarted somewhere else, is it still the same stream? Imagine a scenario where the machine makes a mistake. Instead of destroying you, it creates a copy while you're still standing there. Now, there are two of you. Both think they are the real one. Both have lived your life. Both feel conscious. Which one is actually you? There's no clear answer. And that's what makes teleportation so unsettling. Because it doesn't just challenge physics. It challenges identity itself. It forces us to ask, what does it mean to be me? Is it your body, your brain, your memories? Or is it something deeper, some kind of continuous awareness that cannot be copied? Some scientists have proposed alternative ideas to avoid this problem. One of them is wormholes, shortcuts through space-time predicted by Einstein's theory of general relativity. Instead of breaking you apart and rebuilding you, A wormhole would bend space itself, connecting two distant points. You wouldn't be copied or destroyed, you would simply step through a tunnel in space-time and emerge somewhere else instantly. But wormholes come with their own problems. They would require exotic matter with negative energy density to remain stable. And according to our current understanding of physics, such matter either doesn't exist in usable quantities or may not exist at all. There are even more speculative ideas. Some theories suggest that space-time itself might be emergent, not fundamental, and that at a deeper level, reality could be described by quantum information networks. If that's true, teleportation might one day become a process of reconfiguring the underlying code of the universe. Another idea is mind uploading, transferring consciousness instead of the body. But this leads us back to the same question again. If your mind is copied into another system, is that still you, or just a simulation of you? At this point, teleportation starts to feel less like a transportation problem and more like a question about the nature of reality itself. So where does that leave us? Right now, teleportation as we imagine it, stepping into a machine and instantly appearing somewhere else, is not possible. We can teleport quantum information. We are building early quantum networks, and technologies like the quantum internet may one day allow ultra-secure communication using these principles. But teleporting objects, let alone humans, is far beyond our current capabilities. And there's a real possibility that the laws of physics themselves prevent it from ever happening perfectly. And even if it becomes possible one day, it might not be the kind of teleportation we dreamed of. Because in the end, teleportation doesn't just ask, can we go there instantly? It asks something far deeper. Will we still be ourselves when we arrive? And maybe that's a much harder problem to solve than distance.